So today we're going to look at solving proportions, and I have a bunch of problems here. We're not going to do all of these in this first video. I'm probably going to focus just on the first 6 problems to get us an idea of what it means to solve proportions, and then we'll go on to some of these more complex examples in a subsequent video. So we'll start today just with these examples up at the top. So let me zoom in on one of these here. Okay, so we're working with solving proportions, which means that we need to first understand what a proportion is. And a proportion is simply two fractions that are equal to each other. So for example, 2/4 equals 3/6 is an example of a proportion. Each of those would simplify to 1/2. Those fractions are equivalent to each other. Right? And because it's an equation, we can solve it. So for example, in the problem here on the right, m divided by 5 equals 7 divided by 2, or m/5 equals 7/2, we need to solve for the variable m. And we know we can solve because it's an equation. Okay? Equations are things that we can solve. So you may have learned about cross multiplication, and I want to start this first problem actually by doing something a little bit different to help you understand where cross multiplication comes from and why that process works. So usually if we were solving something with a variable, we would, with a variable and also with a fraction, we would want to clear the denominator. For example, if we had x divided by 3 equals 4, we would want to clear this denominator of a 3, so we would multiply by 3 on both sides. And on the left, if you wanted to write that as multiplying by 3 over 1 to have it look like a fraction, that's also fine, because remember 3 over 1 is equivalent to 3. So on the left, the 3's cancel, because multiplying by 3 and dividing by 3 undo each other. Multiplication and division are inverse operations, so they cancel each other out as long as the number that you're doing the operation with is the same. And on the right, we get 12 because 4 times 3 is 12. So this tells us that the value of x has to be 12 if x divided by 3 is equal to 4. So we're going to do something very similar with this problem. M divided by 5 equals 7/2. Just like in the problem we were looking at to the left here with x, 3, and 4, the variable is divided by a number, and that quantity on the left is equal to some other number, in this case 7/2. So all we're going to do is multiply by 5 on both sides. And this time I'm going to write it as multiplying by 5 over 1 on both sides, because I have a fraction on each side and it just makes it a little bit more neat to me to multiply a fraction with a fraction. It helps me think about it. So the 5's on the left cancel out because dividing by 5 and multiplying by 5 undo each other. So we're left with m, and on the right hand side we have 5 times this original fraction. So if first there were 7/2, there's going to be 5 times as many now. Now there are going to be 35/2. So m is equivalent to 35/2, and if you wanted to write that as a mixed number, that would be 17 and 1/2. As a decimal, 17 and 1/2. Okay? So those are acceptable values for m. Those are all numerically equivalent. They're just written differently. Different formats, but they mean the same number. They would go in the same place on a number line. So let's take a look at another example and start talking about how this applies to cross multiplication. Again, here we have another example where the variable is in the numerator. Here our variable is r. R is divided by 5, and that's equal to 7/4. So again, I'm going to multiply by 5 on both sides. I'm going to write it as 5 over 1 because I'm dealing with fractions, and it just helps me keep things neat and organized. The 5's this time cross out on the right, so I'm left with just r on the right-hand side. And on the left, there were 7/4 to begin with, and now there are 35/4. Okay, and these won't always come out to have 35 in the numerator, I promise, just a coincidence here in the first two problems. So 35/4 as a mixed number is 8 3/4, and as a decimal that is 8.75, which we would read out loud as 8 75 hundredths. And of course, 75 hundredths we know simplifies to 3/4. Okay, so 8 and 75 hundredths, 8 and 3/4, 35/4, those are all the same thing. Our third example here is similar to the first two. Okay? So I want you to pause the video, try it on your own, and then we'll do it together and you'll see if you got the same answer. Again, the numerator on the right has the variable, and we want to clear away the denominator. So we're going to multiply by 4, in fact 4 over 1 on both sides. The 4's cancel on the right. On the left, we had 5/3. We have 4 times as many now, so we now have 20/3 instead of 5/3. As a mixed number, that is 6 and 2/3, because 6 times 3 is 18, there's 2 left over. And as a decimal, that is 6.6 repeating. Remember that if you tried to divide 2 by 3, you would get this repeating decimal of 6. Infinite number of 6's after the decimal there. So we write a bar over it to indicate that it's repeating. So these first few proportions were simple enough to do with one step, clearing a denominator on both sides, and we were immediately able to get an answer from just that one step. The next problems we're going to look at, however, are not quite as simple because now the variable is in the denominator of a fraction instead of in the numerator. So here when we clear denominators, our variable is going to end up not by itself on the first step. So let's do this clearing denominators thing and see how that leads us to cross multiplication. So I'm actually going to clear the variable out of the denominator over here. So I want to multiply by k on both sides, and I'm going to write it again as k over 1, just to remind myself how I'm going to multiply these fractions together. So on the left, as we intended, the k's will cancel out, and we're left with 4 over 1, which I can write as just 4, because 4 over 1 and 4 are the same thing. And now on the right, there were 8 halves, and now there's k times as many. So there's 8k over 2. Now my variable is in a numerator, so I just need to clear away the denominator of this fraction on the right. So I'm going to multiply by 2 on both sides. On the right, I'm going to write it as 2 over 1 because I'm multiplying by a fraction here. And on the left, I'm just going to write it as 2 because 4 isn't a fraction, and here writing 2 times 4 doesn't confuse me because both of them are not fractions. So on the left, we get 2 times 4 equals 8, and on the right, the 2's cancel, and we get 8k over 1, which we can write as 8k. Dividing by 8 on both sides, we get that 1 is equal to k is equal to 1. And if we plug that back in, we would see that 4 divided by 1 is of course equal to 8 over 2. 2 goes into 8 4 times, 1 goes into 4 4 times, so good. We know that our answer of k equals 1 is correct. Let's talk for a minute about how that leads us to the process of cross multiplication. 4 over k equal to 8 over 2. The first thing we did was multiply by k on both sides, writing it as k over 1. And so on the left we got 4, and on the right we had this 8 times k over 2. Okay, 8 times k in the numerator and 2 times 1 or 2 in the denominator. So then we needed to clear this second fraction on the right. We multiplied by 2 on both sides, and we ended up with 2 times 4 equals 8 times k. So let's talk about what you probably know about cross multiplication. Cross multiplication is taking the denominator of one of the fractions in the proportion, multiplying it by the numerator of the other. So you would do 8 times k and set that equal to 4 times 2. Well, look at what we have right here. By clearing denominators, we got what you would get by doing cross multiplication. You would get 4 times 2 equals 8 times k, right? And it doesn't matter whether it's 4 times 2 or 2 times 4 because that comes out to 8 either way. Multiplication can be done in either order. So when we cross multiply, what we're really doing is clearing denominators in one step. So cross multiplication is clearing both denominators in one step. Cross multiplication is clearing both denominators in one step. And when we say clearing denominators, we mean multiplying both sides of the equation by the denominator. So in one step. So again, for example, if we had 3 over x equals 21 over 14, okay, multiplying by x on both sides and multiplying by 14 on both sides, we would end up with 3 times 14, that would be this direction of cross multiplication, equals 21 times x, which would be the other direction. Okay? So clearing both denominators means multiplying by both denominators on both sides of the equation. So multiplying by x and also multiplying by 14 on both sides. As you can see, the 14s would cancel on the right, the x's would cancel on the left, so we'd be left with 14 times 3 equals 21 times x, which is exactly what cross multiplication gets us. So cross multiplication is just a faster way of clearing denominators. That's all it really is. So we're going to do 2 more problems in this video. We're going to practice that cross multiplication process. So in this case, we're going to do 2 times 4, that will clear the denominator of a 2, equals 6 times p, which will clear the denominator of a p on the right-hand side. So 2 times 4 is 8, which equals 6 times p. We want to isolate p, that's the point of solving these equations, so we want to divide by 6 on both sides, because dividing by 6 undoes multiplying by 6. So on the right we get p all by itself. On the left, 8/6, they are both divisible by 2, so we get 4/3 as a simplified fraction. We could also write 4/3 as 1 and 1/3, and also as 1.3 repeating, remembering that when we divide 1 by 3, if we did the long division, we would get an infinite number of 3's after the decimal. So this says 4/3, 1 and 1/3, and this also is read as 1 and 1/3. Okay? We'll do one more example that takes this a little bit further. So here, the new thing is that the variable isn't entirely by itself in the numerator or denominator. In this case, it's in a denominator, and now it has a coefficient of 5. In all the previous problems, the variables had a coefficient of 1. Writing a variable like this without anything written in front of it indicates that there's actually one of those things, right? We don't say I have one apple, we say I have an apple. So I have an x, I have an m, I have a p. Okay? So we don't always write this one, we don't always write this one, it's implied that we understand that if there isn't a coefficient in front of the variable, we know that there's only one of them. In this problem, however, there are 5n in this denominator. Not going to make our cross multiplication any different, just something we have to pay attention to as we do our cross multiplication. So in this direction, we have 5 times 2, and in the other direction, we have 6 times 5n. Again, multiplying both sides by each denominator is the same thing as cross multiplication. Cross multiplication just gets us there a little bit faster. So 5 times 2 is 10. 6 times 5n. Well, if I have 6 piles and each of them have 5 things in them, I have a total of 30 things. So I have 30n in this case. 30 is multiplied by n, so to clear it away we need to divide. Multiplication and multiplication and division are inverse operations. So we're left with n on the right hand side. 10/30ths is the same as 1/3. So 1/3 is our value for n that would make the original proportion true. So that's a little bit about why cross multiplication works, where it comes from, and how to use it to solve some very basic proportions. There's going to be another video on some more complicated proportions when we start dealing with things like this, where there is some addition happening with the variable in a numerator or denominator, and then also some problems where there are variables in two different places, right? The same variable, but in two different places in the equation, and also when we get variables in different locations and then also with plus and minus terms with those variables in different locations. So we'll look at solving these more complicated types of proportions in the next two videos.